Arc fault circuit interrupters, or FSIs, function by observing the current flow in both the hot and neutral conductors of a circuit. FSIs are designed to detect imbalances in the current, which can indicate the presence of an arc fault. If an arc fault is detected, the FSI trips to prevent potential fires. Using a 14.3 cable to feed 2 bedrooms is generally not recommended, as it may affect the functionality of FSIs. With the 14.3 cable, the neutral conductor is shared between the 2 circuit conductors, that is, the hot wires. When one bedroom circuit is on and the other is off, the neutral current will be lower than the hot current for the active circuit. This imbalance can potentially trigger the FSI on the active circuit. Using a 14.3 cable for 2 bedrooms can lead to nuisance tripping. The FSI may trip even when there is no actual arc fault, causing inconvenience. It can also lead to reduced protection. If the FSI trips due to a neutral imbalance, it may not protect the circuit against actual arc faults. To ensure proper functionality of FSIs and adequate protection against arc faults, it is recommended to use separate 14.2 cables to feed each bedroom circuit. This will provide each circuit with its own dedicated neutral conductor, eliminating the issue of neutral current imbalance. The problem arises because FSIs are designed to monitor the current balance between the hot and neutral wires in the circuit. They look for sudden, unexpected changes in current that could indicate an arc fault, which is a dangerous electrical condition that can cause fires. When you share a neutral wire between 2 circuits, as is the case with a 14.3 cable feeding 2 bedrooms, the FSI may not be able to accurately monitor the current balance in each individual circuit. Here's why. Firstly, imbalance loads. If one bedroom has a higher electrical load than the other, the neutral wire will carry more current from the heavily loaded circuit. This can create an imbalance that the FSI may interpret as an arc fault, even if there isn't one. Secondly, harmonic currents. Nonlinear loads, such as electronic devices and LED lighting, can generate harmonic currents that flow on the neutral wire. These harmonic currents can interfere with the FSI's ability to accurately monitor the current balance. Thirdly, ground faults. A ground fault occurs when electricity flows from a hot wire to a grounded surface. Shared neutral wires can make it more difficult for FSIs to detect ground faults, which can increase the risk of electrical shock. So, to reiterate, the recommendation is to use separate 14.2 cables for each bedroom circuit to avoid these potential problems. This ensures that each circuit has its own dedicated neutral wire, allowing the FSI to accurately monitor the current balance and provide reliable protection against arc faults. In addition to the above considerations, the National Electrical Code, or NEC, also addresses the use of shared neutral wires in certain situations. While the NEC does allow shared neutral wires, in some cases there are specific requirements that must be met to ensure safety. For example, the NEC requires that the shared neutral wire be sized to handle the maximum current that could flow on it from all of the circuits it serves. The NEC also requires that the circuit sharing a neutral wire be protected by a multi-wire branch circuit breaker, which is designed to trip if there is an imbalance in the current flowing on the hot wires. However, even when these requirements are met, using shared neutral wires can still increase the risk of nuisance tripping and reduce the effectiveness of FSIs. Therefore, it's generally best to avoid using shared neutral wires in bedroom circuits, especially when FSIs are required. As a reminder, FSIs work by constantly monitoring the current flowing through a circuit's hot and neutral wires. Under normal conditions, the current flowing through the hot wire should be equal to the current returning through the neutral wire. However, when an arc fault occurs, the current takes an unintended path, creating an imbalance between the hot and neutral wires. FSIs are designed to detect these imbalances and quickly shut off the circuit to prevent a fire. There are 2 main types of FSIs: branch/feeder FSIs and outlet branch circuit FSIs. Branch/feeder FSIs are installed in the electrical panel and protect the entire circuit, while outlet branch circuit FSIs are installed at the outlet and protect only the wiring downstream of the outlet. The NEC requires FSIs in many locations throughout the home, including bedrooms, living rooms, dining rooms, and hallways. This requirement is intended to reduce the risk of electrical fires and protect occupants from injury. When installing FSIs, it's important to follow the manufacturer's instructions carefully. FSIs are sensitive devices that can be affected by various factors such as wiring errors, loose connections, and electromagnetic interference. It's also important to test FSIs regularly to ensure that they are working properly. FSIs have a test button that can be pressed to simulate an arc fault and verify that the device trips. If an FSI trips frequently, it's important to investigate the cause of the tripping. Nuisance tripping can be caused by various factors such as shared neutral wires, loose connections, and faulty appliances. If you're unable to determine the cause of the tripping, it's best to consult with a qualified electrician. In summary, using separate 14.2 cables for each bedroom circuit is the recommended approach for ensuring proper FSI functionality and adequate protection against arc faults. This eliminates the issue of neutral current imbalance and reduces the risk of nuisance tripping. If you're considering using shared neutral wires in any other circuits, be sure to consult with a qualified electrician to ensure that the installation meets all applicable codes and safety requirements. The goal is to minimize the risk of electrical fires and protect occupants from injury. So, to break it down even further, consider the specific scenario of a bedroom circuit. Bedrooms often contain a variety of electronic devices, lamps, and other appliances that can draw current unevenly. If two bedrooms share a neutral wire, the current from these devices can combine on the neutral, creating a complex and unpredictable current flow. This can make it difficult for the FSI to distinguish between normal current fluctuations and the signature of an arc fault. Furthermore, shared neutrals can create a phenomenon known as voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit. This can be caused by long wire runs, undersized wires, or high current loads. When voltage drop occurs on a shared neutral wire, it can affect the performance of the FSIs connected to the circuit. In some cases, voltage drop can cause the FSI to trip prematurely, while in other cases it can prevent the FSI from tripping when an arc fault actually occurs. To avoid these problems, it's always best to use separate neutral wires for each bedroom circuit. This ensures that each circuit has its own dedicated path for current to flow, minimizing the risk of current imbalances and voltage drop. When running separate 14.2 cables to each bedroom circuit, it's important to follow all applicable codes and safety requirements. This includes properly sizing the wires, using the correct type of cable, and making sure that all connections are tight and secure. It's also important to label each circuit clearly so that it can be easily identified in the electrical panel. When connecting the neutral wires to the neutral busbar in the electrical panel, be sure to use separate terminals for each circuit. Do not combine multiple neutral wires under a single terminal, as this can create a potential safety hazard. Finally, always test the FSIs after the installation is complete to ensure that they are working properly. Press the test button on each FSI to simulate an arc fault and verify that the device trips. If an FSI fails to trip, it should be replaced immediately. Here's a recap of the key points. Firstly, FSIs are designed to protect against arc faults, which are dangerous electrical conditions that can cause fires. Secondly, shared neutral wires can interfere with the operation of FSIs, leading to nuisance tripping and reduced protection. Thirdly, the NEC requires FSIs in many locations throughout the home, including bedrooms. Fourthly, it's recommended to use separate 14.2 cables to feed each bedroom circuit to ensure proper FSI functionality. Fifthly, always follow applicable codes and safety requirements when installing electrical wiring. Sixthly, test FSIs regularly to ensure that they are working properly. By following these guidelines, you can help ensure the safety of your home and protect your family from electrical hazards. Remember, electrical work can be dangerous, so if you're not comfortable performing it yourself, it's always best to hire a qualified electrician. A qualified electrician has the training, experience, and tools necessary to perform electrical work safely and correctly. They can also help you ensure that your electrical system meets all applicable codes and safety requirements. In addition to the points already covered, it's worth noting that the type of FSI used can also affect its sensitivity to shared neutral issues. Some FSIs are more susceptible to nuisance tripping caused by shared neutrals than others. Therefore, it's important to choose FSIs that are specifically designed for use in circuits with shared neutrals. These FSIs typically have advanced filtering and signal processing capabilities that help them distinguish between normal current fluctuations and the signature of an arc fault. When selecting FSIs, it's also important to consider the specific electrical loads that will be connected to the circuit. Some appliances and electronic devices can generate harmonic currents that can interfere with the operation of FSIs. If you're planning to connect these types of devices to the circuit, it's important to choose FSIs that are designed to filter out harmonic currents. In addition to using separate neutral wires and choosing the right type of FSI, there are other steps you can take to minimize the risk of nuisance tripping. These include ensuring that all wiring connections are tight and secure, avoiding the use of long wire runs, and properly grounding all electrical equipment. It's also important to educate occupants about the proper use of electrical appliances and devices. Overloading circuits, using extension cords improperly, and damaging electrical cords can all increase the risk of arc faults and nuisance tripping. By taking these steps, you can help ensure that your electrical system is safe, reliable, and protected against arc faults. And again, if you're ever unsure about any aspect of electrical wiring or safety, it's always best to consult with a qualified electrician. They can provide expert advice and guidance to help you make informed decisions about your electrical system. Let's now discuss some of the common misconceptions about shared neutrals and FSIs. Firstly, some people believe that shared neutrals are always unsafe and should never be used. While it's true that shared neutrals can create problems with FSIs, they are not inherently unsafe if installed correctly and in accordance with the NEC. The NEC allows shared neutrals in certain situations provided that specific requirements are met. Secondly, some people believe that FSIs are too sensitive and cause too much nuisance tripping. While it's true that FSIs can sometimes trip unnecessarily, they are designed to err on the side of caution and protect against potentially dangerous arc faults. The benefits of FSIs in preventing electrical fires far outweigh the inconvenience of occasional nuisance tripping. Thirdly, some people believe that FSIs are only required in bedrooms. While the NEC does require FSIs in bedrooms, it also requires them in many other locations throughout the home, including living rooms, dining rooms, hallways, and kitchens. The goal is to provide comprehensive arc fault protection throughout the entire home. Fourthly, some people believe that FSIs are a substitute for proper wiring practices. FSIs are an important safety device, but they are not a substitute for proper wiring practices. It's still essential to follow all applicable codes and safety requirements when installing electrical wiring, even when FSIs are used. In summary, it's important to have accurate information about shared neutrals and FSIs to make informed decisions about your electrical system. Don't rely on common misconceptions or outdated information. Consult with a qualified electrician to get expert advice and guidance.